called Rolle's theorem. So if f of x is continuous and differentiable, what rule did I give you that said that it had to be continuous? Like, what was it? When I told you to draw them, what did I say that forced it to be continuous? You couldn't pick up your pen, right? What about the differentiable part? What did I say that made it so it had to be differentiable? No corners. And the f means function. What did I say that made sure it had to be a function? You can't, like, fold back over yourself. So f of x is continuous and differentiable. And the slope between two x values a and b equals 0. So that's like these 2 points that I drew. What's the slope between those 2 points in all these drawings? 0, right? Because I just drew like I tried to draw a level. So Rolle's theorem says then there must exist at least one x value. We'll call it c. Where f prime of c equals 0. So what does f prime of c mean? Flip it back to first semester anywhere before first unit, I guess. What's prime mean? Derivative. So what this is saying is if the slope in like English, if the slope between the endpoints is 0, and there's at least one other place in between where the slope is also 0. We have not done this, right? Yeah. I guess I'm like 99% sure. I'm doing things in a little bit different order this year. Last time. So, is the slope between those two endpoints 0? Yeah. Is it a function? Yeah. Is it continuous? Yeah. Is it differentiable? Yeah. So there must be at least one spot in between there somewhere where the slope is 0. This one has how many? This one's got 3. This one is a kilometer. This one's got several. This one's got, I'm not going to draw all those. This one will screw you. This one's actually got how many? Infinite. Like there's an infinite number of spots with a point is 0. This one just has 1. The point is you can't connect those two dots if you follow those rules without there being a slope of 0. So if you go up from the first dot, what do you have to do? At some point you got to come back down, which is going to make at least 1, which will make the top of the hill. If you go down, you got to come back up, which will make like the bottom of the hill. So does that make sense what the theorem says? Yes? No?
Yes.
Okay. So then you'll be asked to like show the theorem works and find those values. Let's look at a couple of those. Let's look at don't start right now. Hold on. So we're going to read through it, and we're just going to first figure out if the theorem is applied or not. So tell me the endpoint's -3 to 3. So -3 is there. 3 is there. If I connect those two, what's the slope between those two? 0. But I'm going to tell you that this theorem doesn't apply here. Why not? It's not continuous. So as soon as you see this vertical asymptote here, the answer to this question is the theorem cannot be applied. So you wouldn't even do this question. You would just say the theorem cannot be applied because the function is not continuous in that entire window. So look out for that because there will be some of those. Let's find one where we can. What about that one? Does it apply? Does not apply because 0 is not continuous. What if I said like from 2 to 6? Would it apply if I said from 2 to 6? Why not? It's continuous. Why wouldn't it apply? Slope isn't 0, right? So there's two things you got to be on the lookout for. What about that one? Does it apply? It does. So let's go through and see what we would do to solve it. So it can be applied because between -2 and 2 we're continuous, and the slope between -2 and 2 is 0. So if it can be applied, our job is to find the values that satisfy the theorem. So the theorem says that there's going to be a spot where f prime of c equals 0, and our job is to find c. So we're basically just taking the derivative instead of equals 0, which I know it's been a long time since we've done derivatives. How do I take the derivative of that? What rule do I need? Quotient rule? You guys remember quotient rule? Maybe. Bottom times the derivative of the top minus the top times the derivative of the bottom, which is what? What's the derivative of the bottom? Negative. All over. What goes to the bottom? Bottom squared. My job is to set that equal to 0. So what I'm saying is there is a spot in between these two numbers where the slope equals 0. So this is me finding the slope. This is me finding where the slope equals 0. Remember we've talked about if I'm going to find where a fraction equals 0? Yeah.
Why is the slope equal to 0 if, like, because the slope of the line is equal to 0? Is it the slope of the 2 points?
What I'm looking for is where, like, this is going to be the answer.
Yeah.
Whatever that x value is.
Before that, when we decided that it could apply.
Why did I decide it can apply? I decided it can apply because from -2 to 2, the slope between those two is 0.
Oh, just
Which means there must be somewhere else in between these 2 points where the slope also equals.
Okay. So it's those 2 points, the slope equals 0, not necessarily the line at those 2 points.
Right. The slope between. So that'd be like, like this one, but there's other stuff going on here. But I'm really kind of just isolating that and like, okay, I'm looking for that spot.
Okay.
Alright? Good question. Thank you for the question. Other questions? So I got to solve that. So we talked about this before with fractions. If I'm setting a fraction equal to 0, what does the bottom have to do with it? Absolutely nothing, right? The bottom just goes away. Like if I had x over 6 equals 0 and I wanted to solve that, let's say I multiplied both sides by 6, what would you end up with? X equals 0, so the bottom just wipes. So the bottom here does not matter. So you end up with just the top part. Equal to 0. It takes a little bit of the pain out of the quotient rule because you don't have to worry about the bottom. Now we just got to solve that. So -2x squared plus 6x minus -x squared plus 4. What am I doing? You guys solve. you need quadratic formula, which we're not going to do that. But let's just go like up to that point. So it'd be negative 2x squared plus 6x plus x squared minus 4. So you'd have negative x squared plus 6x minus 4. And you can take the negative 1 out, but then you're left trying to find two numbers that multiply to be 4 and add the negative 6, and that doesn't exist. So you'd have to do quadratic formula. The AP stuff doesn't make you do that. I'm not going to make you do that. But I want you to understand like how to get to that point. Questions on anything up until there? Alright, let's look at one where you can actually do it. Does that one work? Does the theorem apply in this case?
Nope.
Or not? Not contiguous. Why don't you try that one? Does the theorem apply? Negative 5 is here. 3 is here. What's the slope between those two? 0. It is continuous, so there should be another spot where the slope is also equal to 0. Somewhere in this window, and there is, it's down there. We're looking for that, that x value. So you guys try to work it out. Take the derivative, set it equal to 0, solve. That was the instructions for something else that we did earlier in the year too. Take the derivative, set it equal to 0, and solve. What else do you do that to find? Be impressed. I know you're all worried about impressing. Nope. Take the derivative, set it equal to 0, and solve. What else does that find? Horizontal. That asymptote. Horizontal blank line. Horizontal tangent line. That's what we're finding, isn't it? The horizontal tangent line? We're just saying there's a horizontal tangent line in between these 2 points. That's all we're doing. Well, I don't want to be distracted. Back there. There's part of it, like started, right? Because the rule is the rule says it's going between those two numbers. So there might be more other ones. So you got like 7. So do the quotient rule. So the bottom times derivative top minus top times derivative bottom over the bottom squared. Bottom squared is going to disappear because we're setting it equal to 0. If I work through, I end up here. I can factor out the negative, and then this factors into minus 7 minus 1, which gives me x equals 7 and x equals 1. And I don't care about the x equals 7. Why not? Because it's outside of our window. The x equals 7 is not in between -5 and 3, so I don't care about that. So this must like circle back somewhere and flatten out again over there, but that's not what I'm worried about right now. The answer I'm looking for is x equals 1. When you got x equals 1 then? Questions? Yeah.
If you put both answers, like if you left both answers on your sheet, would they say it was wrong?
You'll lose points. Because the theorem says like between these 2 points, let's look for those values. Any other questions? Okay, so that's your homework. We'll do, we'll gradually warm up with that tomorrow. Make sure you get there and then do more notes going forward. Come on. Good? We talked about the exam, right? There won't really be like an exam. Probably like a chapter test, if anything. I'm just looking at like an hour and a half class period. Where we're at. It might just be like notes for an hour. I don't know. See. The exam schedule doesn't control us.